You are listening to the Break Time Tech Talks podcast, a bite-sized tech podcast for busy developers, where we'll briefly cover technical topics, news snippets, and more in short time blocks. I'm your host, Jennifer Reif, an avid developer and problem solver with special interest in data, learning, and all things technology. The last several weeks were filled with travel to tech events and giving several presentations and workshops. It was amazing to connect with so many interesting technical audiences and chat about solving problems with technology, but I am also happy to plant my feet at home for a few weeks and dig in on some new things and produce some other types of technical content again. The first thing that I've come across recently is someone asked me how Neo4j handles sparse vectors. I thought I knew what dense versus sparse vectors were, but it turns out that after I did some research and digging, that it was a little bit different than what I was initially thinking. First thing, what are sparse versus dense vectors? They're a different data representation. Dense vectors are what probably most of us are familiar with in generative AI. They're long arrays of floating point numbers representing semantic meaning of the data that's being encoded. Sparse vectors, on the other hand, contain numbers that represent whether or not a word exists in the data, and then fill in the remaining numbers of the array with zeros. The arrays themselves are sparse then, rather than the actual data being sparse. Sparse vectors are a bit more storage efficient. They can be used for some keyword matching scenarios and represent the syntax of the data versus semantic meaning. You might imagine some use cases where understanding how language is structured, what words might come next, or how sentences or paragraphs or even documents are constructed, and looking at the very technical syntax elements of that construction versus looking at how we comprehend or understand the words that are being written for the documents, paragraphs, sentences, what have you. So slightly different use case, slightly different way of encoding data. The next thing I have played around with recently is integrating Spring AI MCP with one of Neo4j's MCP servers. I tried this for the very first time and I did get a sample working. I hope to put together a blog post that will detail more about this and what I did and what went wrong and the things that I struggled with. But the biggest thing that was the hardest was looking at the Neo4j MCP Cypher README file in the GitHub repository, which serves as the documentation right now for the library, and then looking at the Spring AI MCP client documentation page and trying to figure out how to assemble those two things and fit the puzzle pieces together in order to get a working solution. There were a few little things I learned along the way, and it was fun exploring this, playing around with it. I was able to get some, not just the integration working, but was able to work with the text to cipher translation in the Neo4j MCP Cypher server. That was the one I picked to connect to. And then I was able to do some text to cipher queries and play around with that a bit. So it was a lot of fun, and I learned a lot in the process. I hope, again, to share more with you in a blog post. Another thing that I dealt with over the last several weeks was a few weeks ago, I was playing around with Pinecone, the vector database, and Neo4j graph database, and trying to do vector rag and graph rag, and looking at how the two were similar and different. And I wanted to do vector rag with Pinecone and then do graph rag with Neo4j. And I was looking for the map to record method in the Spring AI vector store, and I couldn't find it. They have a map to record and then a map to document as well to map entities that are coming back from the database, from the vector similarity search, back to your Java application entities. And this is really nice. So I thought they had just removed it in one of their most recent releases. But it turns out I came back several days, weeks later, and was looking around and digging around, and I found those two methods in the Neo4j vector store. So this is only implemented in the Neo4j vector store and not several other vector stores, or at least Pinecone and the general vector store class. Now, I'm not sure why the other vector stores don't implement a way to map back to your Java objects, or maybe they do and Pinecone doesn't, or I just haven't found the way to do it. But I found this rather interesting. Now, it is a bit unique to Neo4j in that we are returning nodes and relationships from the database rather than traditional records or documents or whatever the entity is. A lot of times we will add in additional mapping layers to our integrations, the libraries, and anything we might work with, just to make that, using the relationships especially, making that mapping back a little bit easier. However, I did find this unusual that maybe a lot of your vector stores don't provide a way to do that as well, because then you're left doing it custom and doing it manually. Again, maybe I've missed something, but I couldn't find it available in Pinecone, which then meant I would have to map it manually, which seemed like a lot of effort for something that maybe could be included in just the plain vanilla vector store class in Spring AI. Also, over the last couple of weeks, I've presented a workshop, and this workshop was put together by some colleagues of mine, but it focuses on the different types of RAG retrievers and how you should design the way you're pulling the data from your external data source for the different types of questions you might be asking. For instance, a vector search will pull semantic similarity or general knowledge, what is semantically or contextually similar. And then you can extend those results using additional retrieval queries on the end of those. So pulling additional metadata or context from whatever data sources you're looking at, and then adding that to the vector similarity search results. But your questions then need to look for broader or more general information, right? Things that lend themselves well to semantic similarity searches. If your question is regarding a specific entity or trying to do some sort of keyword type search, at least initially, then that's not where vectors shine. For instance, looking at a particular entity and traversing out from there. We actually talk about this in the content piece I'm going to highlight here in just a second, so bear with me for a minute if you're still not sure where this is going. One more thing I explored and kind of found out over time is, and it seems a little bit obvious now that I'm looking back on it, but I was playing around with my Goodreads demo application, the Spring AI Goodreads repository on my GitHub. And it's a book recommendation system that I integrate with generative AI. I tend to search using a keyword search approach, like I would a library or a topic search. When I was a kid growing up, I would walk into the library, I'd walk over to their computer, I'd type in some sort of keyword or topic or genre I was interested in, and it would retrieve the results or anything that might be tagged or included in the book description with that search phrase or search word. But I have to remind myself that that is a very keyword search deterministic system type of lookup. Now we're dealing with something that's much more natural language, more non-deterministic, more conversational, and those keyword search phrases maybe won't be as powerful. Doing a keyword search for something like my book recommendation system is basically doing a fancy synonym finder, right? That's not really the power of large language models. Instead of then searching magical or dragons for my search phrase looking for books, I started using prompts like, I want to read something to ease my stress and relax during a mountain vacation, or I want to challenge my mind and read something about technology. I found that a more conversational, contextual, complicated set of questions met better, more interesting results. Pulling all these different terms together based on my mood, the topic I might be interested in, current interests at that specific time, can produce a more complicated picture that an AI can combine all these different search vectors and find the most likely path combination, including all those things. Versus giving it one keyword search, it's really kind of vague and not enough information for it to pull something that's really highly relevant. Adding a little bit more context actually gives it more data to go on and could help produce much better results. The content piece I want to look at today is your RAG pipeline is lying with confidence. Here's how I gave it a brain with Neo4j. And this ties back to some of the concepts we've already explored earlier in this podcast. I really thought that the author did a great job walking through this, structuring it, working through it methodically, and explaining things along the way. The big term that the author used was that traditional RAG systems have semantic drift, where each step in the RAG pipeline delineates the meaning or loses some context along the way. And the author links this to a game of telephone that you might play when you're kids. where one person either whispers a term or a sentence or something, phrase into the next person's ear or a pipe or whatever you're using as a transmitter device. And then that person hears it and then passes that message on down. By the time it gets to the end, usually whatever it was that was the starting message is totally different and way off base. The author then takes this example and says, your RAG pipeline is doing the same thing. There's some semantic drift over time that occurs based on what RAG drops or misses or whatever. There were a couple of things that the author did to try to combat this. The first was going from basic to smart chunking. Then the next is dealing with semantically blind retrieval. As we talked about earlier on the podcast, sometimes high similarity doesn't mean high relevance. As an example, the author was dealing with different types of employee leave policies. And if someone were searching something on parental leave, vector search would pull anything that's related to parental leave. And it was actually pulling some termination leave policies in with that because it was semantically similar in the chunk. However, you don't want to return termination leave policies to someone looking for parental leave policies, right? So trying to figure out, okay, how do I fix this and improve this? The author dealt with that semantically blind retrieval and trying to go about solving that. Then last thing that the author talks about is that the system prompts can't fight bad retrieval. So trying to take whatever was retrieved and then telling the LLM and the system prompt, do this, don't do that, avoid this, structure it this way, clean this up, was turning out bad results. It's kind of like handing somebody a basket of junk and saying, make gold out of this. The large language model is in the same boat, basically. You're trying to tell it, hey, here's some really crummy results. Try to make something good out of this and tweak this and do this and clean this up. And the LLM just isn't very good at that. So the way that the author combated this is to do some smarter chunking with text overlap. That was going from basic to smart chunking. Then the retrieval re-ranking by traversing the policy type in the graph to narrow down that keyword topic first, rather than just the semantically related topic first. For instance, that leave policy problem that I had mentioned just a minute ago, narrowing down and looking at, okay, I want to focus on parental leave policies and then traverse out from there and pull the related context based on that and not incorporate semantically similar things that might include termination leaves. Then the third thing is to use retrieval that adds to the prompt and not try to use the prompt to negate or bribe the context into a good answer. This week, from upgrading my skills on Spring AI to reassessing and updating my knowledge of general skills, I felt like there was a lot of food for thought. We talked about how sparse versus dense vectors are different, integrating Spring AI with MCP, and then discussed an article on how being thoughtful about solution design produces better results. As always, thanks for listening and happy coding.